Hello friends, welcome to Engineering Funda family. In this video, I'll be solving three very interesting problems based on half power beamwidth and first null beamwidth. Let us have first question over here. See, in first question, for a given antenna, electric field is given by E theta is equals to sin theta. And we need to find half power beamwidth and first null beamwidth. So we are given with electric field, and based on electric field, we need to understand how to identify half power. So first of all, you should know what is the relation in between power and electric field. If you have seen my last video, then you see, in last video I have explained average power, that is equals to surface integration of average power density, where average power density is E square by 2 eta and average power density is eta s square by 2. That is what the case which we have seen it in my last video. So based on that, you can say average power is directly proportional to average power density, that is also directly proportional to electric field square, as average power density is directly proportional to E square. You can also say average power is directly proportional to magnetic field square, as well as you can say average power that is directly proportional to radiation intensity U. The reason is average power, that is solid angle integration of radiation intensity. Let me note down that relation. See, power over here with antenna, power with antenna, that is proportional to electric field square, that is also proportional to magnetic field square, that is proportional to average power density, that is also proportional to radiation intensity. Based on this relation, one can identify half power beamwidth and first null beamwidth, right? Now here you see electric field is given over here. So half power, that is having what electric field? So at half power, what is the value of electric field? Electric field, that is proportional to square root of power, that you can say. So at half power, electric field will be 1 by root 2, right? Now you need to plot electric field over here. See, E theta is equals to sin theta. Sin theta can be easily plotted, right? See, sin theta value, that is maximum at 90 degree, right? So here let us say it is 1 over here, and sin theta, that will be 0 at 0 degree angle and at 180 degree angle. So it is 0 over here. So if you plot it, it is somewhat like this. You see, it is somewhat like this. And on other side also you can plot it. If I say this is 1 over here, then it is happening somewhat like this, right? So this is how sin theta that one can plot. Now see, 1 by root 2, that is what the value of electric field at half power, right? So we need to identify what is the angle at half power. So if you want to identify angle at half power, then 1 by root 2, that is equals to sin theta. So you can say theta, that will be 45 degree angle, right? Theta will be 45 degree angle. So over here at 45 degree angle, if you identify the value, then that value will be 1 by root 2 over here, right? That value will be 1 by root 2 over here. And similarly over here also it will be 1 by root 2 at 90 plus 45. So half power beamwidth, that will be how much? That will be twice times of this theta. So that is 90 degree, right? Now if you want to identify first null beamwidth, then see, first null beamwidth is how much? First null beamwidth, that is a width of major lobe. Here this is major lobe, right? And nulls are appearing at which angles? Nulls are appearing at 0° angle and 180° angle. So if you want to identify first null beam width, then at 180° angle null is there, minus at 0° angle null is there. So that will be 180 minus 0 means 180°, right? That is how one can identify this. So first of all, you should know the relation. Based on that, you can easily solve questions. Let us have second interesting problem now. Second problem is also based on calculation of half power beam width and first null beam width based on electric field. Here electric field is sine square theta. In first question, electric field was sine theta, right? Now here you need to understand difference in plot of sine square theta and sine theta. See here sine square theta, that plot that is somewhat like this, you can observe, right? And sine theta that is happening like this, you can observe. So what is the difference over here? See, as you have sine square, at that time that sharpness will be a bit more. If you have sine cube, in that case beam will be further sharp, right? Means here higher area is there with sine theta, and here you have lower area over here. It is bit sharp towards 90°, right? And here you see it is having bit round shape over here. That is how things are different, right? Now let us identify half power beam width and first null beam width. If you want to identify half power beam width, then first of all you should know the basic relationship in between power and electric field. See, power and electric field, that is related as per P is proportional to E square, right? So at half power, one should know electric field that will be 1 by root 2. If electric field is 1 by root 2 over here, then 1 by root 2 that is equals to sine square theta over here. Then sine theta that is 1 divided by 2 to the power 1 by 4. If you solve this, you will be getting 0.84. So theta is equals to sine inverse of 0.84. And if you solve this, you will be getting theta is equals to 57.33. See, this is what the angle at which this electric field is 1 by root 2, right? So here if I say electric field is 1, right, then 1 by root 2 that will be happening somewhere over here, right? That will be happening somewhere over here, where this angle is 57.33, right? Now how to identify half power beam width? So you see, similarly angle over here that will be having 1 by root 2 value, right? So what we will be doing is we will be calculating 90 minus 57.33 and we will be multiplying it with 2 to get half power beam width. Let me show it to you. See, if you want to calculate half power beam width, then all we can do is here we need to identify this 90 minus this angle. And if you multiply it with this by 2, then you will be getting this much angle, right? That is half power beam width. So here 2 into 90 minus 57.33, that is what giving you half power beam width over here. So if you solve this, you will be getting 65.54 angle, right? So you need to understand first how plot is there. Based on that you can solve half power beam width, right? Now we need to identify first null beam width. First null beam width, that is quite easy. If you want to calculate first null beam width, then you need to identify this angle, that is 0, and this angle, that is 180. So 180 minus 0, that is 180 degree only. So first null beam width is 180 degree, right? That is how we can identify this. Now let us solve third interesting question. Third question is based on calculation of half power beam width and first null beam width from radiation intensity. If you observe here, normalized radiation intensity that is given, that is u of theta is equals to cos square theta into cos square 3 theta. And based on that, we need to find half power beam width and first null beam width. So first of all, you should know the relation of power and radiation intensity. In first problem, I have explained that, right? Power that is directly proportional to radiation intensity. So based on that relation, we can easily identify this. So let me note down that relation. See, power is directly proportional to radiation intensity. So one should know at half power, what is the value of radiation intensity? Radiation intensity will be also equals to half. If radiation intensity is equals to half, then half is equals to cos square theta into cos square 3 theta, and if you take square root, then you will be having cos theta into cos 3 theta, that is equals to 0.707, means 1 by root 2, that is 0.707. Now see, we need to identify angle over here, and that you can identify by trial and error, right? See, this is what I have identified by trial and error in my calculator, and that is somewhat 14.32, right? So now I have theta at half power, that is 14.32. So what will be half power beam width over here? But obviously it will be double of this angle, right? I'll show you how it is double of this angle. I have took this example from CA Balanis, and here I'll be solving it first. After that I'll explain you how it is double, right? So if you want to calculate theta of half power beam width, then that is 2 into this angle. So if you do this, then 28.64, that is what the angle of half power beam width, right? Now we want to calculate first null beam width, right? We want to calculate first null beam width. So but obviously with first null beam width, we will be having nulls over here, right? So at first null beam width, this u that will be equals to 0. So cos square theta into cos square of 3 theta, that is equals to 0. So here you will be having cos theta, that is equals to 0, or you can say cos 3 theta, that is equals to 0. If cos theta is equals to 0, then theta is equals to 90 degree. And as if you talk about cos 3 theta is equals to 0, then you can say theta is equals to 90 by 3 means 30 degree, right? So that is how two angles are appearing. That is how two angles are appearing. Now let me explain you how plot is that. See, function is what? Function is cos square theta into cos square 3 theta. So if you want to draw that by hand, it is bit complicated one, right? But here you can understand one thing. See here, cos square into cos square is there. So as if cos square into cos square is there, then at 0 degree, there will be maxima, right? So you will be observing plot is somewhat like this, you see, where at 0 degree, maxima will be there, right? At 0 degree, maxima will be there. So at half power, see, we were been having angle that was 14.32. That's why we have multiplied with 2 to get this much width, right? Now here you see first minima that is happening at 30 degree, right? So, but obviously over this side we will be having minus 30 degree. So what will be first null beam width? Then first null beam width, that will be this angle 30 into 2, right? So that will be 60 degree. So that is how we can have first null beam width. But that you can understand after watching this plot. This plot will not be given to you. But sometimes students are asking me like, why don't you multiply 90 into 2? See, 90 into 2, that will be 180 degree, right? So that will be always giving you false answer. The reason is, you see with this plot over here, we have 90, over here we have 180. So that is not having first nulls. First null is happening with this first major lobe, right? So this 30 into 2, that will be resulting into first null beam width. And see, as and when you have sine square, at that time you will have to understand this. See, in case of sine square, theta, you will be observing plot is bit more sharp towards this, right? In case of cos square theta, plot will be more sharp towards this. If you have cube, then further sharpness will be there. But that is bit difficult to draw it by hand. So you need to understand that by calculation, and then you will be getting proper clarity in terms of calculation, right? I hope you have understood this. Still, if anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.